I just kind of use them to color a little bit. All right, what we call the zeros of a function. These are x-intercepts, and that's just going to be where the graph crosses your x-axis. Zeros of a function. It's an x value where the corresponding y value is going to be 0. And they're always of the format, it'll be some number, and then the y coordinate is going to be 0. These will be a little bit easier to see on these graphs today. And we're going to use this more, like I said, on the back, but I just wanted you to know what it was because we're going to identify them in the graphs on the front before we flip this over. And then what we're going to focus on the front is identifying intervals where a graph is increasing or decreasing. Okay, so the way this works, for both things we're going to do today, we are going to describe x values for where the graph is increasing or decreasing. For both things we're going to do today, you are going to go from left to right on the graph when you describe these. And I'm just going to kind of sketch. Basically, as you kind of, we're just going to I'm going to trace the graph. I'm going to do it with a highlighter. And basically, if you are drawing down, as you would like trace with your pen, pencil, highlighter, whatever you're using, that would be an interval that is decreasing. If, as you're tracing with your pen, pencil, highlighter, whatever you're working with, you're drawing up, that is going to be where the graph is increasing. Now, that's just in general for any graph. Specifically for quadratic graphs, this is going to switch at the vertex. So one side of the graph will be increasing, one side of the graph will be decreasing, and it switches at the vertex if you're working with just a parabola. If you're working with a different type of graph, it's different, but for our graphs that we're going to work with, we're going to have two intervals and it switches at the vertex. All right, so here's all I'm going to do. I'm going to come down to this lovely graph. I drew like a giant graph here, right? So the vertex, you guys can see that's either the maximum or minimum point. Here it's the minimum. And I think it's just 5, -4. And for this graph, I'm going to go ahead and just kind of sketch in the axis of symmetry. That's that AOS is an abbreviation for that. Remember, it's just a vertical line. I call it vertexal to help me remember that it's x equals a number. But it's just going to be a vertical line that splits the parabola right in half. It has to go through the vertex. The equation should just be x equals whatever the x coordinate of the vertex is. For this example, that's going to be 5. All right, now just a couple review questions. Could you tell me the domain of the graph? Just raise your hand and tell me, what's the domain of this parabola? What are the possible x values? What do you think? Yes, okay. Negative infinity goes left and right forever. Negative infinity to infinity. Who could tell me the range for this graph? What would you write for your interval for the range? Yeah, awesome. Okay, now, this is the only thing that you're going to have today that's going to have a bracket. And I'm going to explain that in a second, because when we work on these intervals of increasing and decreasing, we're going to use intervals like we've been doing for domain and range. The only one that should have a bracket, or the only one that describes y values, is the range. All right, no brackets on anything else. I'm going to explain that to you in a second. To describe intervals of increasing and decreasing, like I mentioned, you want to literally start on the left side of the graph, and I'm just going to trace, I'm literally going to trace the graph, okay? So if I start over here, and I'm going to trace it from left to right, and I'm just going to draw on this, am I increasing or decreasing? Right, decreasing. We're just going down, all right? So that whole thing is decreasing. And I'm going to write that on my line roll here. This is decreasing. All right, when I get to the vertex, that's where it's going to switch. Do you guys see, as I turn at the vertex here, I'm drawing up for the rest of the graph. And so that side, after I switch, this side would be increasing. All right, so it's kind of like two halves, if you will. Now, to describe the interval, and use this if you want to, I found this can be kind of helpful. So if I'm all the way, we're doing x values here. If I'm all the way to the left of any graph would go to negative infinity. So the whole time, if I went way far over, I would be tracing down on this graph for all these x values until I got here. And this really trips people up. It's not the y value. You're switching at this x value because we're switching from left to right. So the x value where I switch is going to be the 5. So we're going, when I trace this, I'm going from left to right, so we're describing x values, just like you would for a domain. So I'm decreasing, decreasing, decreasing. At the 5, then I switch over, and the rest of the graph, I know I'm going up, but I'm also going to the right forever. So as I continue to go to the right forever, we would be drawn up, so that would be positive infinity. Okay, now, if you like this, I do this myself. So I literally draw the interval on the graph. So from negative infinity till I switched over at the 5, that interval is decreasing. So I'm going to just come over to the side here. That's decreasing. So it'd be negative infinity, comma 5. Both would have parentheses. Does anybody know why I have a parenthesis and not a bracket at the 5? It doesn't stop it. Yeah, you're not increasing or decreasing. Like if I'm tracing here, this is basically flat. We're not increasing or decreasing. It's the very bottom of the graph, so I'm not doing anything. I'm not going up, I'm not going down, so it's not a bracket, it's a parenthesis. Because then at that same number, when I turn to go this direction, then I'm going up, so that's positive. So it's a bracket on this one too. So the increasing interval starts at 5 and it stops, well, it doesn't stop, it goes on forever to infinity. So from 5, for the rest of the graph, we would be tracing up forever. So the increasing interval is from 5 to infinity. Parentheses on all of the increasing, decreasing intervals. And then just to show you guys what I was talking about at the very top, the zeros are just where the graph crosses the x-axis. So on this graph, if I'm looking at it, cross the x-axis right there at 1, that's actually the point 1, 0. So you wouldn't just want to write 1, you want to write the point. The other point is over here, and that one should just be 9, 0. So a 0 for a graph, it's the x value where you guys cross the x-axis as a coordinate. It's an x-intercept when you see it on a graph. Is anybody having a question? All right. So same problem, different graph. And you guys can see vertex here is going to be, looks like 1, 8. Axis to symmetry, again, that's going to go directly through the middle of the parabola there. Whoops. And you're describing that line. So if I describe a line, it's got to be an equation. I call it vertexal to help me remember it. Should just be x equals a number, and that number should just match the x coordinate of your vertex. So all your, oh my gosh, sorry, I'm shaking this all over the place. All your x values here are 1. All right, now, domain for any parabola, right? Doesn't matter whether it turns up or turns down. It's always going to cover the whole x-axis, negative infinity to infinity. What would you guys write down for the range for this graph? Perfect. Negative infinity, and then we're going to have a bracket at the 8. This is the only one that's going to have a bracket because we actually touch that point, and it has nothing to do with increasing or decreasing. It's just a point on the graph that we're going to touch. The range is the only thing that describes y values. Everything else we're doing today is describing x values. All right, so same thing I did on the last one. You're going to start on the left side of the graph. All right, now, I know the arrow is pointed down, right? That's going down forever. But you want to trace it like you're tracing it from left to right. What am I doing on this first piece? Am I increasing or decreasing? Because we're going up if we're tracing it. So this is actually, I know it's got that arrow that's pointed down, but I'm actually increasing as I'm moving from left to right to trace this graph. When you get to the vertex, then turn the corner here, and then the rest of the graph, I'm drawing down on this. So this is going down. So then this side would be decreasing. All right, now this is very tricky. All right, X values. So we're not going to use 8 in any of my description here. All right, so think about all the way to the left, because I'm tracing this from left to right, would be negative infinity. This whole time I'm increasing until I get to the vertex. The X value there is 1. This is where I switch directions, because I'm going from left to right. This one is particularly tricky for people, because the rest of the graph is decreasing, but I am traveling to the right. I'm not describing the Y values here, so I am traveling to the right. So I am actually going to positive infinity for my X values, even though the graph is going down to negative infinity. That really trips people up. But you are going from left to right. You are not going up and down to describe Y values. So the graph is decreasing, but the interval is actually going to be positive. So again, like I just draw these on the graph and then just use them. So all the way to the left forever until I get to that vertex, I would be drawing up on that graph. So it'd be increasing, and that interval would be from negative infinity to 1, parentheses on all these. At 1, you're flat. At the top, you're not increasing or decreasing. It's where you're going to turn in the corner, and so that's why it's a parenthesis, not a bracket. Then the rest of the graph, starting at 1, and I know, again, this is tricky. It's going down, but I'm going to the right. So I'm going to, as I go to positive infinity, like if I was at an X value of 100, I'd still be decreasing, but you're describing the X values for me. So that interval should be from 1 to positive infinity. It's always tricky if the graph is turning upside down for people to do those intervals. You're describing the X values. And then just to do the zeros real quick to practice this, looks like we're crossing at -3. So -3, 0 would be a point, and 5. So 5, 0 would be the other place the graph crosses the x-axis. We're going to use those for what we're going to do on the back. Is anybody having a question so far? Now, on the graphs on the back, we are going to identify intervals where the graph is positive or negative. So this actually has nothing to do with the vertex. Okay, so graph is going to be considered positive where the Y values are positive. And I just kind of abbreviated that. If you're talking about a negative interval, it's where your Y values are negative. Now, increasing, decreasing switches at the vertex. These intervals, this switches at the zeros. All right, so here's how this works. I'm going to come down to this graph just real quick underneath here, and I'm going to highlight the x-axis. Okay, now literally I would tell you, think about the x-axis there if you're doing positive, negative. Literally thinking about it like almost like surface of a water if you were at the ocean or the lake or something. All right, if you are above the x-axis, all these points above the x-axis, those are positive Y values. So this part of the graph, this would all be positive. If I'm below the x-axis, almost like being below the water level, then these pieces are negative, and there's 2 of them. So there's going to be one positive interval, and then this one's negative, this one's negative. So when you're doing that, the x-axis is going to serve as where you're going to switch, and you switch specifically at the zeros. So we want to identify that for this graph here. So this looks like it's going through -3 and +5. So that's where I'm going to switch. So my zeros, -3 and 5. So I'm going to write down the coordinates of those points real quick. And you can use this if you want to, like I did on the last question. I'm just going to write a -3 here, that's the x value, and I'm going to write a +5 here. All the way to the left, just like the graphs on the front, would be negative infinity. All the way to the right would be positive infinity. This is a little bit tricky because there's going to be 3 different intervals here. On the other side, there's only 2. This is going to have 3. So as I'm going from negative infinity until I get to the negative 3, that piece of the graph, all the y values are negative there. So I'm going to do, which highlighter am I using here? So this interval from negative infinity to negative 3, that is negative. Does anybody know why I use a parenthesis and not a bracket on the negative 3 here? Yeah, if you're on the x-axis, if your y-coordinate 0, 0 is not considered positive or negative. So that's why that's going to be a parenthesis and not a bracket. Okay, now at the negative 3, I switch, and it's like I hop above the x-axis, like I'm jumping out of the water, basically. And this whole piece, all these y values are positive until I get over to the 5. Remember, you're traveling from left to right. So that interval will be from negative 3 to 5. That interval is positive. Okay, now after I get to the 5, and again, this is tricky because this turns upside down. After I get to the 5, then I'm back down below the x-axis. So I'm going from left to right as I'm doing this. As I keep going to positive infinity, the rest of this graph is all going to have negative y-coordinates. So I want to describe the possible x values there. That's from 5 to positive infinity. The rest of the graph is negative. So if you have two intervals, if you guys remember, you just use a little, it looks like a little U kind of, it's called a union symbol. It just means I have two different intervals where the graph is negative. Is anybody having a question? I'm going to try one more with you. Same thing, positive, negative, and this one's turned right side up. And then I've got a couple special cases at the very bottom just to show you what you might run into. All right, your zeros here look like negative 13 and negative 1. So I'm going to write down those 2 points. Those x coordinates are negative 13. The y coordinate would be 0, negative 1. Y coordinate's always 0 where you're crossing the x-axis. Now, I'm going to highlight my x-axis here real quick. So this is the dividing line for where I switch from positive to negative. Anything above the x-axis is going to be positive. So I've actually got two pieces here that are positive. So to the left of the negative 13 and then to the right of the positive 1. Those pieces are both positive. And then in between the negative 13 and the 1, this whole loop here, this has all negative y values. So on this one, you're positive up here, you're negative down here. It's switching over at those zeros. And if I'm going to go ahead, I'm going to write these intervals on the x-axis just for myself, just to be helpful. So if I'm going to the left and I start to approach the right, I start with negative infinity. That goes up forever. I would always have positive y values until I got to that negative 13. So for positive, from negative infinity to negative 13, that part of the graph is positive. When I get to the negative 13, and remember, that's not positive or negative because it's at 0. When I switch over here from the negative 13 all the way till I get to the negative 1, that interval, negative 13 to negative 1, all those points are negative. So from negative 13 to negative 1. And then once I hit the negative 1, we go back above the x-axis, so all our points are positive there. So at the negative 1, all the way the rest of the graph is going to be positive. So here I'm going to put a little union symbol between these, and I'm going from negative 1 to positive infinity. The rest of the graph is positive. Is anybody having a question? Okay, I have just a couple of special cases at the bottom just to show you guys how to write this. So I'm going to do these little tiny graphs last, but this one here to the side. This has a vertex that is also a 0. So the 0 where it touches the x-axis is also the vertex of the parabola. So just one here, it's just 5, 0. Now, you guys can see I never, go ahead. Yeah. Sorry. If you guys are looking at that graph, which we'll do in a second, you can see that that graph in the bottom left corner, it never goes below the x-axis, right? So should I just say for my intervals, you're good. Okay, so it never becomes negative, right? This never comes below the x-axis. So I don't have any negative part of that graph. Would I just put as my interval negative infinity to positive infinity for the positive, where it's positive? Let me know. Should I just do one interval or should I do it differently? Is that whole graph always positive? Is there a place where it's not positive? It's really nitpicky, but technically, since this touches the x-axis, you have to write two separate intervals because I'm not considered positive or negative at a 0. I know this is super weird, but the whole graph, this is a 5 here, this whole graph is positive except for that one point. So this would actually, if your vertex touches the x-axis and you're describing positive or negative, you're going to actually have two intervals. It's going to be from negative infinity to 5, and then from 5 to infinity. The reason for that is I'm not actually positive or negative at that vertex, so I'm basically excluding that value by writing those two intervals. I know that's super weird, but that's the technical way you're supposed to do that, because the entire graph is not positive. Now, that is not the case, these two on the side. If you look at these two on the side, right, this graph never dips below the x-axis. This graph doesn't even touch the x-axis. It doesn't have any zeros. So if you don't have any zeros, your entire interval is either going to be positive or negative. So I never touch the x-axis. The entire graph, so from negative infinity to infinity, the whole thing would be positive. Down here, it's kind of the opposite. So again, I never touch the x-axis, but everything is below that x-axis. So on this one, I would not have any positive interval. The entire graph is below the x-axis, never touches it. So it'd be negative infinity to infinity for all the points being negative. Is anybody having a question? Okay.